Hello everyone, and it's been a while that I haven't uploaded at least one YouTube video in my channel, so I would like to apologize about that. It is due to the fact that I have personal priorities that I must focus on, and there are some priorities that are so important that I need to put a lot of time on it. So I wanted to say that to those who waited, I would like to say thank you. And it's completely understandable that uh, the number of subscribers uh, are decreased, I think, by two or by one, but that's okay. All it matters is that is I came back. All right. So here we're going to continue our last discussion about trigonometry. So we're done with angle of depression and elevation. So we are here now. We're going to answer a test about right triangle trigonometry. So we will be having some of the problems here in this video and we're going to answer it. So I think let's begin, guys. So let's begin. So first problem. What is the Pythagorean theorem? A. Sum of the squares of a leg and the longest side of the right triangle is the square of the other leg of it. B. Sum of the squares of legs of a right triangle is the square of the longest side of it. C. Sum of the squares of all sides of a right triangle is the square of the longest side of it. And lastly, sum of the squares of legs is not the same as the square of the longest side of it. Mm. So, which is the correct answer? So let's recall what Pythagorean theorem is. So in Pythagorean theorem, we have this formula: a squared plus b squared is equal to c squared, where a and b are the legs of a right triangle, and the other, which is c, this is the hypotenuse side or the longest side of the right triangle. So let me label this as the legs. All right. So basically, the correct answer here is letter B. I letter B. Sum of the squares of legs of a right triangle is the square of the longest side of it. Okay. So the sum of the square of legs. So meaning the what do you call this one? The sum of the square of the legs here. To rephrase it, it's like each measurement of the legs, you're going to square it. So we have A, so square it, plus B, and you square it, so B squared. Then what you have here is just the same as the square of your hypotenuse, or the square of the longest side. So that is Pythagorean theorem. All right? It's not letter A, because letter A, sum of the squares of a leg and the longest side is a square of the other leg. So let's assume that A is the leg given here. Then here, sum of the squares of a leg and a longest side of the right triangle. So that means a squared plus c squared. Then square of the other leg, b squared. So this is not Pythagorean theorem, all right? Because here we know that c is the hypotenuse, right? A and b are the legs. So this is not correct, all right? And of course, C is not the correct answer because here it says that all sum of the squares of all sides of a right triangle is just the square of the longest side. So this is also wrong. And lastly, letter D, sum of squares of leg is not the same as the square of the longest side. This is obviously wrong. All right. So the answer here is letter B. Okay. Wait. Oh, wait. Maybe my camera is not that. Wait. There we go. I those are wondering what I'm trying to answer or what I'm trying to write. All right. So there we go. So the formula should be a squared plus b squared is equal to c squared, not a plus c squared is equal to b squared. All right. From now on, I'm gonna put my camera here, right? Bottom right. All right. So let's go to the next problem. Which of the right triangle we can apply Pythagorean theorem? A. Obtuse triangle. B, acute triangle, C, right triangle, and D, none of the above. I think the clue here is already in the first problem, right? It is right triangle. All right? Recall that in the Pythagorean theorem that we have a right triangle and then assume that the base of the right triangle is A and then B is like the height of the right triangle. And of course, we know that commonly C is the longest side of the right triangle. So here, if this is a right triangle, we can apply Pythagorean theorem. All right? So if and only if it's a right triangle. If it's not a right triangle, then Pythagorean theorem is not applicable. All right? So the answer here is a given right triangle. So next, in a right triangle, how do we know if a leg of it is an adjacent side? A, if it is beside the referred acute angle. B, if it is not beside the referred acute angle. C, if it is beside the right angle. And lastly, D, if it is beside the exterior angle. So let's just say I have a right triangle here, right? I have a right triangle. Right, let's suppose we have a given angle here, and this is our referred angle, all right? This angle is an acute angle. So what is an adjacent, hold on. Yeah, we're going to know if a leg of it is an adjacent side, right? So meaning we're going to focus on these two sides because these two are the legs of a right triangle. Now, how do we know if it's adjacent? It's simple. If it is adjacent to the referred acute angle, or in other words, it is beside to the angle here. So which of the leg is beside of the acute angle? It is actually the base of the right triangle. So this one is your adjacent side because this adjacent side is beside to the referred acute angle. All right. So the answer here is letter A. Of course, if you're asking me, what if we are referring to an acute angle at this position? Like, what if the acute angle is here? So, what will happen? Then, the legs of your right triangle will be also changed, where this is no longer an adjacent side, but rather this side is an adjacent side already because it is beside the acute angle that we are referring to. Okay? So that is how you know if the leg of it is an adjacent side. Next, here are the correct trigonometric ratios except A, cosecant theta is equal to the hypotenuse side or, divided by opposite side. B, tangent theta is equal to the opposite side all over adjacent side. C, cosine theta is equal to hypotenuse side over adjacent side. And D, sine theta is equal to opposite side over hypotenuse side. So the correct answer here actually is letter C. This is actually wrong. All right. The rest, wait, the rest, yeah, correct. The rest of the trigonometric ratios are correct. Cosecant theta is equal to the ratio of hypotenuse side and opposite side. So that's okay. Tangent theta, correct. And sine theta is also correct. This one, on the other hand, this is not correct. It should be instead adjacent side all over the hypotenuse side. This is how we write the ratio for the trigonometric function cosine. Okay, so it's a all over h, not h all over a. Right? So the answer here is letter C. Next problem. Which of the following ratios is equivalent to cotangent theta? A, opposite side is to hypotenuse side. B, adjacent side is to opposite side. C, hypotenuse side is to adjacent side, or D, adjacent side is to hypotenuse side. So the correct answer is basically what? Opposite all over adjacent. Cotangent theta is equal to, oh wait, no, adjacent all over opposite, yeah. Adjacent side all over opposite side. That is the answer here. Now, but the question is, you see, this is not in fractional form, rather this is like in ratio form. It's like 1 is to 2, 4 is to 10. It looks like this basically. So how are we going to know which of the following is equivalent to this cotangent function? So let's take a look. Opposite side all over hypotenuse side. All right. It's just the same as this. So we will have O all over H. Adjacent side is to opposite side is just the same as A all over O. Alright? So basically, what's on the left, that's like the numerator of the fraction, and what's on the right, that's the denominator of the fraction. Right? So I hope you get the idea on how I convert this ratio into a fraction. So basically, the answer is letter B. All right. Remember that cotangent theta is A all over O, adjacent all over opposite, which is just the same as this form, which is adjacent side is to opposite side. All right. So that is the correct answer. Letter B. All right. Next, if we have a given adjacent side of 4 units and hypotenuse side of 5 units, then which of the following trigonometric ratios is equivalent to the ratio of these sides? A. Sine theta. B. Cosine theta. C. Tangent theta. And D. Cotangent theta. Let's have like a short recall. Sine theta, if you're going to know its equivalent ratio, it's basically opposite side all over hypotenuse side. So opposite is to hypotenuse. All right. Now, you see, we have a given adjacent side of 4 units and hypotenuse side of 5 units. So the thing is, we have a given of hypotenuse, but not the opposite side. So A is not the answer. All right. How about cosine theta? In cosine theta, its equivalent ratio is adjacent all over hypotenuse. That's the equivalent ratio. Now let's take a look. Here we have a given adjacent side and we have a given hypotenuse side. And now that we have a given adjacent side and hypotenuse side, we can actually relate it to cosine because in cosine we only use adjacent and hypotenuse. So therefore our answer here is letter B. Because if you get the ratio of these sides and you're going to find its equivalent, then for this case it's cosine theta. But is there any trigonometric ratio that we can equate it aside from cosine? Well, the answer is yes, and that is the reciprocal of cosine theta, which is secant theta. Secant theta is equal to the hypotenuse all over adjacent. So here we can say that secant theta is also the answer to this problem, but again, for this case, it's cosine theta. All right? So this is the answer. All right. So let's proceed to the next problem. Oh wait, this is not KED, okay? What are we going to do to find the angle in a given trigonometric ratio? It's to do, not KED. There's an error here. Right? So what are we going to do to find the angle in a given trigonometric ratio? A. We will find the angle algebraically. B. We will use the given trigonometric function to find the angle. C. The ratio of the two sides of a for a given trigonometric function is the angle itself. Or D. We will find it by using an inverse function of a given trigonometric function. The answer here is obviously letter D, right? Letter D. Suppose we have a given trigonometric ratio of sine theta is equal to opposite all over hypotenuse. And you want to know, you want to find this angle. You get me? You want to find this angle. Now, the thing is, number one, you can't do it algebraically. It's impossible, right? Two, uh, in letter B, we will use given trigonometric function to find the angle. Well, the thing is, this is already a given trigonometric function, all right? But the thing is, this is a bit broad. Like, okay, you're going to use it to find the angle, but in what way? All right. So uh B is not the valid answer here. C, ratio of the two sides for a given trigonometric function is the angle itself. This will not tell you the value of your angle, right? This will not tell you the value of the angle, all right? You may get its what do you call this one? You may get its exact answer here, like from fraction into a number. It could be decimal or whatever, but still, that's not the angle. So for us to find the angles, we need to get its inverse function. We need to get the inverse function of your sine. All right. So all we need to do is just put what was one? Wait, it sounds wrong. All we need to do is just imagine that you're looking for sine. So the you're looking for the angle. So just put sine on the right. So we will have theta is equal to. Once you put sine on the right, we will have actually a somewhat negative one, but that's not the negative one and negative one value. Okay, this negative part right here, this is not negative one. It may look like one, like right now, for me, it looks like one, but this is not negative one. It's like we have a given function. And when you find its inverse function, okay, this is f inverse of x. That is how you write an inverse of a function. So this is not negative 1. It's a basically a representation. So likewise in this case, if you see sine and then it's negative 1, that is not actually a negative 1, but rather it's a representation of its inverse function. So going back, okay, we have this one. Then we will have its input, and the input is this one on the right. So it's O all over H. That is how you're going to find the angle, which is getting the inverse function of a given trigonometric function. All right? So that is the answer of this problem. Okay? So let me just erase everything here so that we can answer the next question. Okay, whoa. All right, let me just put my camera up. All right, there we go. There we go. Suppose we have a given hypotenuse side and an acute angle. How do we find the uh how do we find the adjacent side and the opposite side of a right triangle? All right. So here we have given choices. A, adjacent side is equal to the hypotenuse side times sine theta, and for the opposite side is just hypotenuse times the cosine theta. B, adjacent theta is hypotenuse times cosecant theta. Then for opposite side, it's hypotenuse side times sine theta. C, adjacent side, all you need to do is multiply the hypotenuse side by cosine theta. And for the opposite, multiply hypotenuse side by the secant theta. And lastly, for adjacent side, just multiply the hypotenuse side by cosine theta. And for the opposite side, it's uh it's hypotenuse side times sine theta. What is the answer here? So the answer here is obviously letter D. Letter D is the obvious answer here. All right. So here we have a given right triangle, right? And then let's just say we have a given acute angle here and we have hypotenuse. We want to find the adjacent and the opposite side. So, of course, we already know that the adjacent is just beside the angle, and then that is not beside the angle, that is your opposite side. So here, all we need to do is just take a look on this case, right? So here in this problem, if you're going to find the given side of the adjacent, like in this problem, all we need to do is just multiply it, multiply the hypotenuse by cosine theta. And likewise for the opposite, so all you need to do is multiply the hypotenuse by sine theta, right? Also, that's the same thing if the acute angle is from above, right? Like it's here, right? So if we refer that angle, like that's angle above, right? Of course, what happens is that the legs, the representation of the legs of a right triangle are switched, where this side is already the adjacent and bottom is the opposite. And remember that in here, if you're going to find the length of the adjacent, you will multiply still the hypotenuse by cosine theta. All right, and the same thing goes on here for their opposite. We will do the same thing times sine theta. All right, although there is an equivalent for this one, like there's an equivalent. I mean, instead of h times cosine theta, there's actually another way for us to solve this problem. But we will discuss, no, not discuss, that sounds wrong. But I will not discuss it here because maybe I'm revealing answers for our next problem. All right? So, point being, the answer is letter B. Okay? So now, let's go to the next problem. This one. What is the difference between an angle of elevation and angle of depression? A angle of elevation is an angle that is above the horizontal line of sight, whereas the angle of depression is an angle below the horizontal line of sight. B angle of elevation is an angle that is below the horizontal line of sight, whereas the angle of depression is an angle above the horizontal line of sight. C angle of elevation is an increasing angle, whereas the angle of depression is a decreasing angle. And lastly, angle of elevation is a decreasing angle, whereas the angle of depression is an increasing angle. The answer here is letter A. All right. To have a short review, all right, or recall rather, suppose we have a horizontal line of sight, and this is in dashed lines. If we're going to form an angle starting from here and it goes up, all right, goes up, and then let's just say there is a terminal side or a line connecting to that or what do you call this one, a line that tells you the final distance of uh at what part that the angle wait, how should I say this, let's just say we have a line. Okay, let's just say we have that line, and that line tells you how far does the angle form. Much better, all right? So yes, so despite how far it goes, it still goes what, above the horizontal line of sight. So that is your angle of elevation, or I'll just put angle sub E, right? Or you know what? Yeah, just put elevation, much better. So this is angle of elevation. Now, what if it goes downward instead? Like you started to form an angle by going down. So we go here, all right? So we have an angle here. And that angle, that is no longer an angle of elevation, but rather depression, all right? Because you form an angle by going down, all right? So the answer for that is letter A, right? So we're done with our first part of our test. So here, what we're going to do is we're just going to wait for this video to be uploaded by me, because here I think we're just going to we're just going to solve some problems here. All right. So I hope you have learned something in our video today. All right. So that will be all. See you soon.